Hey guys, welcome to our first video for Key Concept 2, which is all about right triangles and trigonometry. This first target is covering trigonometric ratios. If you haven't watched the vocab video for this target, I would definitely stop right now and go do that first, because more than any other target, making sure you understand what the trigonometric ratios are is very important for going on and answering these questions. Okay. If you have watched it, awesome. Let's go ahead and get started with example 1. Example 1 asks, what are the trigonometric ratios for angle A? The first thing I'm going to do is I'm going to show where my angle is. I'm looking at this angle. Okay. The next thing I want to do is I want to make sure I label my opposite side, my adjacent side, and my hypotenuse. Okay. I think the hypotenuse is the easiest one. It's across from your right angle. Alright, so here's my right angle, drawing an arrow through the middle of the triangle across. That's my hypotenuse, right? Your hypotenuse is always across from the right angle. Then my opposite side, or my adjacent side, I think is the next easiest one. It's the side that's next to the angle. It's touching the angle, right? So this side here is touching that angle. And then my opposite side is across from the angle I'm looking at, which in this case was angle A, right? So I have my opposite side, my adjacent side, and my hypotenuse side. And we'll definitely be practicing labeling those a whole bunch more in class. So, looking at this, if I'm finding my trigonometric ratios, I'm going to start with the sine of A. And you do have to say write sine, and then you have to write what angle you're finding the sine of. You can't just write sine. It's the sine of something. So this is the sine of A. Right? So remember, going back, we have that nice, nice bright color. We have our nice way to remember these, which is SOHCAHTOA. And I'll be writing that down a lot. You should be writing it down a lot, and you should be trying to memorize all of these, right? So sine of A is equal to opposite over hypotenuse, right? Because it's O and H. So my opposite side is 30, right? And my hypotenuse is 34. And then always make sure you reduce your fractions. 30 over 34 is really 15 over 17, right? I'm reducing that fraction. So the sine of A equals 15 over 17. So I'm going to do the same thing for cosine. Cosine of A equals, well, for cosine is AH. A over H. So my adjacent side is 16. And my hypotenuse is 34. And again, always make sure you reduce your fractions. So I have really 8 over 17. And my last trigonometric ratio is tangent. So the tangent of angle A, right? And tangent is opposite over adjacent. So O over A. My opposite side is 30. And my adjacent side is 16. And again, always make sure you reduce your fractions. So that's 15 over 8. All right, let's go ahead and look at our next example, solving for unknown sides of a triangle. Once if I know an angle, right, I can use these trig ratios to solve for the unknown side. So the first thing I'm going to do, just like I did before, is find out where my angle is, or mark where that angle is. Now again, I'm going to label my sides. So that hypotenuse, it's across from the right angle, right? Then my hypotenuse is across from my right angle. My side next to my right angle, or sorry, my side next to my marked angle is my adjacent side. And my side across from my marked angle is my opposite side. Okay. So once I have everything marked, I think it's easiest to kind of look at what do I have information about, right? I don't know anything about my hypotenuse. I don't have any measurement over there. So I'm not going to use my hypotenuse. I'm going to use this. My adjacent side is 33, and my opposite side is x. So again, thinking back, we have that SOHCAHTOA, that nice way to remember things. So here we have O and A. So I want to look at my different trig ratios and see which one uses O and A, right? So Ka, or TOA, right? And the TOA, the tangent, is the one that uses O and A. So the tangent of my angle, remember I have to write the angle, so this is going to be 55 degrees, equals O over A. So the tangent of 55 degrees equals x over 33. Okay? Right? Because O is x, A is 33. And now I'm just solving for x. Right now, x is being divided by 33, so I'm going to multiply by 33. So I have 33 times tangent of 55 degrees equals, right, and my 33's divide away. 33 divided by 3 is just 1, so it's just 1x. Right? Once you have x by yourself in these problems, we're really just going to be using our calculator, because this tangent of 55 degrees, there's no way you can do that without a calculator. So, on my calculator, I'm typing exactly. So, I'm going to have 33 times, right, and then all of these things, see about that for a second, all of these things are trig ratios. Anything we're going to be using is right here, and it says trig. And if you have your own calculator that's not one of the Inspires, they're right along the top part of your calculator. They are not too hard to find. They're actually hard to find on the Inspire. So they're under this trig menu, and you can see they're all just right in here. So I'm looking for the tangent one. Be very careful. We are looking for tangent, not that tangent with the little -1 by it. We're going to be coming back to that later. But right now, we just want the tangent. Okay? The tangent of 55. Hit enter. And that's all it is. Okay? So here, x equals, and that was 47 point, and we're going to round to the 10th place. So 47.1. And x is a side, so it's not a degree or anything like that. It's just the side length is 47.1. Alright, looking at B. I'm going to do the same thing where I mark my angle. I have 45 degrees. And then I have to mark all my sides opposite, adjacent, and hypotenuse. So my hypotenuse is across from the right angle. And then my adjacent side, right, is next to the marked angle, right, meaning adjacent to whatever angle you're looking at. So that's my adjacent. And the opposite side is across. Right? So again, I want to look for the sides I'm actually going to be using. There's nothing next to my opposite side. So in this one, I'm going to be using adjacent and hypotenuse. Okay. So again, looking up here, the ratio that uses adjacent and hypotenuse is my cosine. So here I'm going to do the cosine of 45 degrees equals adjacent over hypotenuse. So the cosine of 45 degrees equals, well, my adjacent side is x, and my hypotenuse is 44. So here I'm going to multiply by both sides by 44, and I get 44 times the cosine of 45 degrees equals x. Okay. And again, I am just typing that into my calculator. So I get 44 times, under my trig menu, is the cosine, right, of 45 degrees. And here I'm going to get 31.1. So x equals 31.1. Alright, looking at C. Alright, looking at C. Right, here I have two variables. I have x and y. So I still want to first start by marking my angle. Right, here's 50 degrees. I can mark my opposite side. Or sorry, let's start with our hypotenuse. Right, across from the right angle is my hypotenuse. Across from my marked angle is my opposite side. And next to that marked angle is my adjacent side. Okay. So starting there, right, let's decide first which variable we're going to solve for. So I'm going to say, let's solve for x first. Okay. So in solving for x, for now, I'm going to ignore, right, that side. I'm only going to use, I'm going to ignore y. I'm going to only use x and 12. So again, this is one that it has a and h. So if I'm using a and h, I'm going to be using cosine. The cosine of 50 degrees equals adjacent over hypotenuse. The cosine of 50 degrees equals, my adjacent side is x, my hypotenuse is 12. Okay. So with this, I'm going to multiply both sides by 12. So 12 times the cosine of 50 degrees equals x. And I'm going to type that into my calculator. So 12 times, under trig, go over to cosine of 50. And I get 7.7. So x equals 7.7. Now that I've used x, I'm not going to worry about it anymore. Now I'm going to look at y and 12. Alright, so now I'm looking at O and H, and O and H would be sine. So I'm going to look at the sine of 50 degrees, right, and sine is over H. So the sine of 50 degrees equals, right, well, my opposite side is y, and H is 12. So again, I'm going to multiply both of these things by 12. So I get 12 times the sine of 50 degrees equals just y. Again, that's all I type into my calculator. 12 times, under trig, the sine of 50 degrees. And I get 9.2 if we were rounding up. Alright, that's all we're going to look at for today. So pretty much all we were doing was writing trig ratios and then solving for the variable. Okay? I'll see you guys tomorrow.